Hey folks, in our last video we added some persistence to our app with TinyMongo, which is exactly like PyMongo, pretty much. PyMongo is the way that you interact with a big MongoDB cluster out in the internet. And all of the code that we're writing here for TinyMongo is essentially the same. Like a lot of this stuff that I'm showing you will work exactly the same across both. There are two failings to TinyMongo, but fortunately we can fix both of those, and we're going to fix one of them in this video. But before we do that, let's finally make our app stop asking for our password all the time by adding a save password function. So to do that, let's go into our GUI, and in our login layout, let's add a little SG checkbox that asks, do you want to save the password? And we're going to give that a key of save pass. And that's all we have to do to add the checkbox. But we need to come down to our connection logic here. And let's check if the check is checked. So if value save pass. And let's also make sure that they've actually given us a password. So if the password field is empty, this is going to be false. Both of these things need to be true, and if they are, let's take whatever were given here and add that to our settings password key. So that is equal to value password. And you'll recall we're setting this up here where it's either going to pull the settings file, which is a dictionary, from the database, which looks like this. So right now the password is lol. And if that's not available, it'll create that dictionary in the settings. And that's what we just did right here, where we're saying, okay, the settings password is now set to this. But we need to now save our settings into the database. So let's create a new function in our database file here. Save settings. And we want to do an update this time. So in all these previous examples, we've been doing inserts where we insert a whole dictionary in and that becomes a new document. But when you're updating, you want to give it two dictionaries, one to say which document you want, like some identifiers, and then another dictionary that updates the specific elements that you want to update. So let's look for a document that has an ID of settings, which, as you recall up here, is exactly how this document appears. And then we just want to update the password. If this was a bigger document, like if there was lots of different settings in here, we could be interacting with them, or we could actually do inserting new stuff into the document. But right now there's only a password in there, and that's all we want to interact with. So let's Dropbox settings password. All right, so go back into our GUI here. That should be already imported, and it is. We can now just save the settings. All right, yeah, that looks good. But there's going to be a problem here. Although we're saving the settings, remember the way that we're determining whether or not we want to actually show this login panel is by the state of our app. So if it's in the init state, it's always going to be showing the login panel. So let's go back into where we're loading up the settings. So here it's grabbing whatever the latest version of the database is, and it's going to say, well, if the settings password is anything other than blank, let's change the state here to connected, else. Then we'll take our init here and plug that in right here. So actually, I just remembered a problem with that. If I do this now, that's not going to work because the database already has a password set. Okay, yeah, let's leave it as is. I'll just delete it here in the password. And now we've got our save password check. And let's change that to lol and connect. And it updated in the database. So that's great. So let's move on now to these shares that we're trying to share. The first problem here is you notice that all the directories are /, and that's wrong on Windows. So let's fix that and make our app look good across all operating systems. Like even if you're only ever working on Mac or only ever working on Linux, it's helpful to know how to make your app work across different platforms. So that is what we're going to focus on here. You notice that the browse function actually gives us that. So we can't make this stop doing the forward slashes, but we can fix it in our program. So let's do that. This is where we do the add share. Let's take that share path. I'm going to need to import OS, and I'll need shutil, and I'll need datetime later. So we'll just grab all these. These are all built-ins. You don't need to pip install them. So let's take the share path, and we're going to now make it a normalized path using os.path. And there's a whole bunch of useful programs in here. We're going to be using the norm path. We're taking share path here. And now this is going to be, it's going to look right. Before I do that though, I said I want to start writing stuff here and I want to be able to show this off to you. So let's change the way that this whole confirming and sharing thing works. Let's make sure that this is giving us a true return before it does any of the reloading and stuff. So if we return a false here, it's just going to stay up there and we'll be able to show errors and things like that. So right now it is going to return false here, so it's not going to do any of this stuff. If I go in here, and oh, you did notice that when the program launches now, it's skipping the login. So that worked correctly. If we go in now to browse a file and pick it here, it's printing out the correct Windows style here. So that's great. We've solved one problem. Now let's get the actual file name, because sometimes we're going to want the specific file name and not the whole big path. So let's separate that. And once again, we can use a helpful tool in OS path, which is the base name, which is going to just grab the file name. I won't show you that. You can take my word for it. And now let's think about what we want to be doing with these things. So this is going to be like a Dropbox where if you change a file, it's going to update this across other computers. And we're going to have stuff that's going to check for when the files that we're paying attention to change. And we're going to want to cache those changes so that if the file continues to be changed while we're doing a transfer to the other computers, it doesn't break anything. So we need to set up a whole caching system. And to do that, we're going to need like directories and stuff to store our caches in. And we want those caches to be uniquely named so that we can have multiple caches of the same file. That way, if things continue to change while you're transferring it, or I'd like to add in a revert function. So like in all these software version control stuff that I use, it's really handy to be able to revert any changes to a file. Let's just add that to the system, because we can do that. So let's save multiple caches of things. Let's figure out how we're going to stuff this into our programming here, though. So first we need to create the cache directory. So let's call this cache path, and let's do os path join. And here we want to get whatever the current working directory is. So that's easily enough with os get current working directory. And we're going to combine this current working directory with where we want to stuff these things. So let's use a f string here. We'll say make a directory called cache. And then in that, we're going to have one that's specific to this file. So it's going to be the file name. But we want to have some sort of a unique identifier for this. And a good thing to use for this is time. So it'll be the file name underscore and then the time. But we can't just like do this, because this is going to create a date time object and you can't just easily put that in there. Let me show you briefly how Python makes it easy to get quick dates. Just import date time. And date time, UTC now. There's UTC now, which will give you universal time. And then there's also now, which will give you whatever time your present machine is using. So if you're in East Coast, then you're going to get a different time from UTC time. It's usually handy to use UTC time for a lot of things, so that's what we're going to use here. But if we use UTC now, there's also a few ways to get a quick and easy dirty string out of that. So one that we can use here is timestamp. So that gives us the time in seconds since the Unix epoch. So that's a nice big number that's always going to change. Like that changed again. Like it's always going to be a unique number that we can use to append to our folder here. So let's take our cache time and do a timestamp from that. So now we know the place that we want to stuff this. We need to actually go in and make the directories. And there is a make directories function of OS, or make directory. But this will only make the last portion of a directory. Like if this cache here doesn't exist, and it doesn't, it won't be able to make this. So instead of, I suppose we could manually make a cache, but let's do this programmatically here. Instead of make directory, we want to make directories. So that was mkdir, and now it's make dirs. And make dirs, we want to make this whole big path file here. And let's rerun our code here, and you'll see that happens. Should happen anyhow. And it did, yay, all right. So we got our cache, and we got our database.py underscore a whole bunch of seconds. So we now have unique directories being created. We are ready to actually do the copying. I realize that might have been a lot of stuff beforehand, but we needed to make sure we were ready for this, and we're ready for this now. So the shell util module has a whole bunch of different ways of copying things. We want to use copy to because that's going to preserve some of the metadata, like when a file was last changed. So let's use that. And this is really easy. Now we just take the share path, which is the original file that we want, and we tell it where we want this to go. So we're going to do another OS path join, and this time we're going to join our cache path to the file name because we have to give it the file name that we want this to end up in. And that should work, but let's make sure that it does. Like, let's actually write in a serious check here to make sure that is going to work. So if OS path is file, and once again, we're going to do an OS path join of the cache path with the file name. If this is a file, then that's good. But if it's not, that's bad. So we definitely want to return false on this, and we want to give the user some sort of a notification that this is not working. So let's make a notification system real quick here. We'll just go into our GUI and add a alert status or share, which will take a message, and we'll just update the window share status, which is a label that we made but we haven't used, and we're going to update that with the message. And while we're at it, we should probably check to make sure that the actual file we're getting here is there, and that the user didn't somehow screw up. So let's double check that the initial file is there with the same, if not OS path is file share path, then the file's not found. So let's tell them dripbox GUI alert share file not found. And we want to return false. And it's dripbox GUI alert share failed to create cache. All right, so this is going to be easy to test this one. It's a little bit more tricky to test this one, but we can let's just test that and see what happens. We'll take a file here, and I'll just mangle this, and it should screw up, and it did. Yay! So we're getting the first character, that the F in file not found. We need to extend that label because right now it's just 1 character by 1 character long. So let's go up to our layout share, and here's our share status that we created, and we'll just add a size, which is a tuple. We'll make it 40 characters long and 1 character high. And now let's see if this is working, and it is. All right. So we are successfully caching files, or actually I haven't shown you the copy actually working. It'll work. And if it doesn't work, we'll get the error message. So let's move on. But now we've got like a lot of new data that we're not accounting for in our database. So let's start to save the way that we're actually going to be using this. So the file name should be the file name rather than the share. But we do want to keep the original share path. So let's save that. And we're going to still be interested in the progress. But let's start saving information about our caches. And we can do that inside of a list. So this list is going to contain every single cache that we make of an individual file, which we will identify by the file name. And inside of this list, we're going to save the, you see I'm making another dictionary inside of this. We're going to save the cache path, and we don't need to append the file to that because we already have the file name up here. So we're going to save the cache path, and then the cache time, so we know what time that this was saved. But this is where we're going to hit the first problem with TinyMongo. And it's going to be a very teachable moment, so I'm going to let it happen. So let's pick this file, and uh-oh, it's locked up. It's totally locked up. You can't do anything. Yep, my program broke. And usually you're used to your Python program printing out an exception here to let you know what happened. But because of the way that we're doing this asynchronous GUI thing, the exceptions are just happening, and it's now like hidden underneath everything else that's going on. So we need to figure out what's going on. You see that it did actually make that new directory, and it did copy over the file correctly. So all of this code was working. This is the problem code. Let's figure out what's going on here. And a way to do that is to put the problem code inside of a try except. Exception as E. So now any kind of errors, and this exception here is just a blanket any kind of errors, we're going to call E, and we want to print them out. And I'm going to show you 2 different ways to do this. We just print it as E, but we can also print out the REPL, or the repr of E, and you're going to see that we get slightly different information from this. So if we go in here, and now we try to copy database over here, we get object of data type is not JSON serializable. Let me drink water before I try to say that word again. Serializable. Oh, wow. That is so much easier when I've drank some water. Okay, so it can't turn this date-time object into something that we can store in JSON here. So that's a problem. Now, in PyMongo, it automatically does this. But in TinyMongo, it doesn't for some reason. We're going to have to address that. So let's get rid of our exception, because it told us what we wanted it to. But you notice that when it's printing the E, it tells us that very specifically that. But it doesn't tell us what type of error it is. And sometimes that's useful to know. Like sometimes this will give you more information. Like it'll give you like the specific, this is the specific thing that's screwing up. But this repr thing will always tell you the type of that error. So you can change your exception from being a general exception to a specific exception. And sometimes you really handle that and completely solve any problems by knowing exactly what kind of error that is. Like, oh yeah, okay, well, sometimes that happens. There's what you do to make it work. But now that we know what the problem is, let's get rid of our try and accept. And we need to now go back into where we are making our TinyMongo client, and we're going to have to make our own client altogether. Now that might sound like a lot of work, but it isn't, because we're going to use the wonderful world of object-oriented programming to create our own client using the existing client. So from the TinyMongo serializers, I'm going to import the datetime serializer. And TinyMongo is actually using TinyDB. I'm trying to remember how this... Yeah, TinyDB serialization. We're going to import a middleware. Serialization middleware. Okay. So I know we haven't done any specific object-oriented stuff yet, but everything that we've been doing is already object-oriented. All right. We created this object, and we did that. Like, we're using a lot of objects. This isn't anything to be worried about or scared of. All right. It's very simple. We create the class and we can name it whatever we want. So we're going to be making the TinyMongo client. And instead of having to rewrite everything that goes into that TinyMongo client, I'm just going to take that TinyMongo client and say that the TinyMongo client inherits all of the stuff. And I can show you real quick here. Like, this is that code that it's now inheriting. It's saying, give me all this, put this inside a TinyMongo client, and now I can override things and add new functionality. In this case, what I want to do is I want to override the property that is called underscore storage. And we'll go into this declaration stuff with the decorators later. One very important thing to keep in mind here is that anything you def inside of a class, you need to pass the self. This is how your object knows where it is in relation to everything else. So you could have multiple versions of any object, but this is how it knows what's going on inside of one specific instance of that object. So you always need the self inside of anything that you're passing around in here. So inside of this storage thing, we're going to add see, it has this thing, but right now it's just returning the default storage. We're going to completely overwrite this to use our own storage method. So we're going to create a serializer, which is going to use the serializer middleware. Oh, wait, no. Is that right? Yeah, okay, that's right. And now serializer, we're going to register a new serializer, because you see that, and we're actually making objects inside of objects. We just took this whole big middleware class and we said it's called serializer, and we're going to use the register serializer method of that class to add in our own datetime serializer. So to do that, we're going to use the datetime serializer that's already built into Mongo but not used for some damn reason, and we're going to call that the tiny date. All right, and now we need to return this serializer. So that's our first introduction to object-oriented stuff. It's really easy, and it makes coding a lot more efficient when you don't have to rewrite everything from scratch. We just rewrite the bit that we didn't like, and we added new functionality. And so now we come down here to where I'm instantiating this TinyMongo client, and instead I will instantiate a TinyMongo client. And this will work now. So you see it's reading from the database to get the stuff that it is displaying here. If we go in and we add a new file here, it didn't lock up. So that's the important thing to keep in mind here. So it created the new files, and it is actually creating these new entries in the database, which you can see here. See, we've got our tiny date, and this is a mess. I'm sorry. It prints off in one big string. Here, I'm gonna blow it up anyhow, so I'll just show you what's going on. Like this cache that we're creating, which is a list of this is the document it created, and you'll notice that since I'm on Windows, it's putting these extra slashes because a single backslash is an escape character, so you need to put a second one behind it in JSON here. And it's saving the time now, and it's not giving us any errors, as you can tell, because my program isn't locked up. So we've solved that problem. Let's blow up the whole database here. We'll just delete all our caches and let's take a look at what we've created. Oh, whoops. That's right. It's still running, so it's not liking me trying to delete it. All right. So we're handling for all these errors that could possibly occur, and then we're stuffing this new entry into the database after we've successfully copied. And let's return true if all of this goes according to plan. And this should all work now. So we need to set a new password. Okay. And it's going to save that. And now we can add a share. And now we have that in here. And I want to point out something real quick. If we explore this file here, the date modified, because we haven't modified this. This is the one file we haven't modified, is from the 17th of December. If we go into our cache here and look at this, it retains that metadata. So it's got all the other useful stuff in there. On Linux, this becomes an even greater issue because it's going to try to save a lot more metadata. But that's why we use copy2 instead of just the regular copy. Because if we use the regular copy, it's going to forget all that and just say that it was modified now. So like this folder itself was modified now. I think that covers everything I want to cover in this video. We're getting really close to the point where we're going to get into all the networking and stuff next. So take it easy, folks.